Hello students, so this is Vaishali here and today we'll discuss about the thermodynamics. Now what is the thermodynamics? Thermodynamics is the branch of science which is concerned with heat and how heat is related to the work and energy. We discuss here the relation between the heat and work. The relation between the heat and energy. So first of all, we'll discuss about the thermodynamic system. What is a thermodynamic system? It is a collection of a large number of particles or matter on which we focus our attention. It is a thermodynamic system. Now thermodynamic systems are mainly of three types, students. First one is the open system, second one is the closed system, and third one is the isolated system. Open system is the system in which the system exchange matter as well as energy with the surroundings. It exchange matter as well as energy with the surrounding. For example, we consider example when tea is placed inside a cup, what happens? Vapors come out of it. In this case, mass is also exchanging. The system is exchanging mass with the surroundings, correct? Also the heat is also exchanged here. So second one is the closed system. In this system, we exchange only energy. Only there is exchange of energy and we don't exchange mass with the surroundings. For example, when the cup is covered with the lid, what happens? Heat vapors there, exchanging, no heat vapors, no vapors coming out of the cup, right? That means no energy exchange is there. Energy exchange is there but no mass exchange is there. Next one is the isolated system. In this system, there is no exchange of mass and no exchange of energy. When the system neither exchanges mass and nor this energy, this is called the isolated system. For example, when tea is placed inside a thermos flask, what happens? No mass exchange, no energy exchange. Next we talk about variables. These are the variables required for the description of a system. Like we'll talk about pressure, volume, temperature. All of these are what? These are the thermodynamic variables. Because to describe the state of any system, we need these state variables. We need these thermodynamic variables. Pressure, volume, temperature, internal energy, entropy. We'll study this further. Next is the equation of state. Now what is the equation of state, students? It is the mathematical relation that describes the relation between the thermodynamic variables of the system, the state variables of the system. For example, we take the ideal gas equation. We know the ideal gas equation is equal to PV is equal to nRT. So this is the ideal gas equation, correct? In this case, P is the pressure, V volume, N is the number of moles, R is the universal gas constant. Universal gas constant means we take this value 8.314 joule per mole per Kelvin, correct? And T is the temperature here. So also we can say that it is equal to 1.986 calorie per mole per Kelvin. So this is the ideal gas equation. So equation of state is mainly the relation, mathematical relation between the state variables of the system. Next we will discuss about the thermodynamic process. What is the thermodynamic process? In the thermodynamic process, the system change from one set of variables to the another set of variables. There are four thermodynamic process. First is the isothermal process. Isothermal process means the temperature will remain constant here. Temperature constant means change in temperature 0. Isobaric process. In this process, pressure remains constant and change in pressure is equal to 0. Next is isochoric. Isochoric process in which volume will remain constant. So change in volume is always 0 in isochoric. Adiabatic process. Heat will always remain constant here. So change in heat will be 0. Next we'll talk about the steady state. Now what is the steady state, students? A thermodynamic system is said to be in the steady state if all its state variables remain constant with time. They are not changing with time, they are remaining constant with the time at each point within the system. So we call that the system is in steady state. Also, so next we'll talk about how to find out the work done in the thermodynamic process. Let us consider a cylinder which is containing gas inside it. Let us consider a cylinder containing gas inside it. So what happens here? This is the piston. If the gas is enclosed inside it, then what happens? The gas will exert pressure on the piston. The pressure can move, the piston can move upwards or the downwards. If the piston pressure is applied by the gas is filled over here. Okay, so the gas is filled over here, pressure is applied on this. Now, if the piston will go upwards, what happens? Let us take this distance is dx. If the piston has moved from here to here, then let us consider this to be the small change in position dx. What happens? Force will be pressure into area. How? We know that pressure is force per unit area. So pressure will be here, force per unit area. So force will be pressure into area. Now if displacement is dx, then change in work done is equal to F dx. F is equal to pressure area dx. Total work done is equal to how much? Pressure area dx. Now what is this? This is small change in volume. We can take this dV. So work done will be integration of P dV, correct? So we'll take this formula of work done from now onwards. Now what happens? If the gas is expanding, in any case, if the gas is expanding case, so work done will take work done as positive, and if compression case, we take the work done as negative. Not this. We'll use this in the numericals. So if the gas is expanding, we take work done as positive. If the gas is in compression, that means we take the work done as negative. Next one is indicator diagram. What is the indicator diagram? The graph between P and V. The graph between P and V is called the integrator diagram. Let us take this small volume dV. And if I ask you to find out the area of this diagram, indicator diagram, what will be the area here? We know area under the graph will take this, correct? Area under the graph. This will be equal to P dV. Area, this is the small area here. Total area will be integration of P dV. And we know integration of P dV is equal to work done. So if someone asks you to find out the area, just find out the work done. And if the examiner asks you to find out the work done in the question and the graph is given, just find out the area, because work done will be equal to the area under the graph. So next we'll talk about the sign convention. Sign convention. Suppose this is a graph PV. In this graph, how we'll find out the work done here? To find out the work done, what we have to do? Just take area under the graph, first thing. Second thing, sign conventions. What will be the sign conventions here? Just see the tracing of the area. This is the area, draw the area. Now see the tracing. Tracing is going this side, this side, this side, and then going upwards. What is this? Is it clockwise or anti-clockwise? This is clockwise. If this one is clockwise, tracing of the graph, this area is clockwise. In case of clockwise, we'll take work done as positive. And if, for example, this is the graph, so our first step here is how to see the sign convention. Just make the tracing of the area. First make the area, then tracing. Tracing will go like this. This is anti-clockwise, and we have already discussed that in case of anti-clockwise we take work done as negative. So getting point? Correct. Next, let us take an example. Suppose this is the graph. We have given this. In this case, first we'll see, we have to find out the work done here. In question it is given that PV graph is given to us and we need to find out the work done. How to find out the work done here? First of all, we'll see the sign conventions. To see the sign convention, we see the tracing of the area. This is the area. How to see the tracing? Tracing is here clockwise. Clockwise means work done will be positive here. Next step, we need to find out work done. To find out work done, we find the area. Area is how much? Now, some students, what they do, area of a circle is pi r square. Correct? Now, pi r is, we'll take this change in volume, and we know that this is pressure. We know here pressure is constant for both the systems. We take the pressure constant. So, can we write this? Change in volume. Change in volume, some of students write V2 minus V1 by 2. Change in pressure P2 minus P1 by 2. So, we'll take this. This is the area of this graph. Now, some of students think that why we are writing this? Why can't we write A is equal to pi change in volume whole square? Or some of students complain that why can't we write this? Area is equal to pi change in pressure whole square. Now pi change in volume is how much? V2 minus V1 by 2 whole square. Similarly here P2 minus P1 by 2 whole square. Is this area correct? Or this area is correct? Or this area is correct? Which area is correct in this case? We have discussed work done is positive. Now what will be the area, or we can say work done, this, or this. See students, if we talk about mathematics, this is correct, and this is also correct. But फिजिक्स में ऐसा नहीं होता. फिजिक्स में स्टूडेंट्स फॉर्मूला जो है जब तक करेक्ट नहीं होता, जब तक करेक्ट नहीं माना जाता, जब तक उसका वो डायमेंशनली करेक्ट ना हो. दिस इज नॉट डायमेंशनली करेक्ट, दिस इज नॉट डायमेंशनली करेक्ट, बट दिस वन इज डायमेंशनली करेक्ट. Getting my point? So we will not take this. This is wrong. This is wrong because they are not the dimensionally correct formulas. So we will take this formula. This is very important. You will make mistakes in the exam. So please note it down. So next we'll talk about work done in isothermal process.